Okay, now that we've got the speed of the object at ground level, let's go ahead and find out how much mechanical energy it lost on the way down. That is, how much mechanical energy was transferred to the air, where it stirred up the air and warmed up the air and also transformed into thermal energy within itself. So we had some expressions up here for amount of energy transferred was initial energy minus the final energy. Percent transferred then is the amount transferred divided by the initial. I'm going to go ahead and write this as percent transferred. I'll go ahead and substitute this expression in for the amount of energy transferred, so I get equals EI over EI minus EF over EI, then all times 100%. So I want to go ahead and copy that down here. E transferred slash transformed is equal to EI minus EF over EI times 100%. And I think I'll go ahead and divide that into each of the terms and get E transferred is 1 minus EF over EI, all times 100%. So now I just have to write down what EF and EI are. That'd be 1 minus, this will be the kinetic energy at ground level plus the potential energy at ground level, all divided by the same sum initially. So at the release point, oops, that's an I, then times 100%. Okay, let's get up here and see what I'm going to use for a reference level. I think I'll call the ground level my reference level. So initially the object is up at some height HI, and finally HF equals 0, so we got no potential energy in the after picture. So a before picture, it'll be up high and moving at 7.77 meters per second, and then in the after picture at the reference level and moving at that speed that I found. So we can say there's 0 potential energy at the end because it's at the reference level. And then this can be expressed as 1 minus, that's a 1/2 mvf squared divided by 1/2 mvi squared plus mgh sub I, where the h sub I is the 35 meters. Now the thing is, the masses cancel. I think it's a good thing too, because I don't believe they gave us the mass. An object, yeah, it would have said of mass such and such. So we don't need the mass, and we don't have it. So this percent E transferred, so what I called it up here, and it should have been that right there. Yeah, that's what I wanted to copy down before. Is I think I'll just multiply this top and bottom by 2. So 1 minus VF squared I squared plus 2gh sub I, and then times 100%. Or the percent transferred is equal to, let's go ahead and substitute values with the units. We got minus VF 18.92 meters per second and the VI was 7.77 meters per second. And we'll put a big right parenthesis there, and then times 100%. So I substitute that into the calculator and evaluate. I get 52.0%. And I believe that's what they wanted. What percentage of the object's initial mechanical energy is either transferred or transformed? And that's what we found. So that's